Going to have a slant. You're going to have a removable. What is your very first step whenever there is a quadratic? Factor. So what I need for you all to do, and from the beginning, yes.
Will it just tell you there's a slant?
No, you have to know that it's a slant. So how do we know, looking at this function, that it's a slant? Can somebody answer that? Top heavy, yeah. So because we have a degree of 2 on the top and a degree of 1 in the bottom, it is top heavy. So we have a slant, which means that where it says, I need to revise this for next year, because it should say slant or horizontal, like it says on your homework, because you can't have both. So this one doesn't have a horizontal asymptote, it has a slant. Okay, so let's go ahead and factor the numerator. So what would be my 2 numbers? I'm going to factor it on this side. 2 numbers that multiply to be x plus 1. Positive 3 and negative 1. Okay. So now that we have everything factored, we can answer our questions. First question is our roots. A root is the same thing as an x-intercept. How do we find, now is this a special case? Let me ask you that. Is it one fraction, or do I have a number being added or subtracted in the back? It's just one fraction. So because it's just one fraction, you're looking at the numerator. Set both of those equal to 0 and write them as ordered pairs. So I'm going to give you a second to do that. Take the x plus 3, set that equal to 0. Take the x minus 1 and set that equal to 0. So you should get negative 3, 0 and positive 1, 0. Who got that? So this one has 2 x-intercepts. So I'm going to go ahead and plot them both. On the x-axis, I'm going to put a point at negative 3, and I'm going to put a point at 1. Okay. In order to find the y-intercept, it doesn't matter what kind of equation it is, you substitute in 0 in place of x. Okay. When you do that, you're going to have negative 3. So 0, negative 3 is my y-intercept. Does anyone need me to explain that again? The definition of y-intercept is the y value when x is 0. And when I substitute in a 0, this is going to become a 0, this is going to become a 0, and that's going to become a 0, which is going to leave me with just negative 3 divided by 1, which is negative 3. Your vertical asymptote will always come from your denominator. And that's going to be written as an equation. So if x plus 1 equals 0, then x equals negative 1. I'm going to go ahead and graph that in. I'm going to use a highlighter, I think. Use my highlight function. Okay. Now, this doesn't have a horizontal asymptote. This is a slant. So we need to do synthetic division whenever it's a slant. What number goes out here? I think I heard it. What'd you say? -1, right? That -1 is whatever your vertical asymptote is. Whatever number, maybe you want to write this in your notes because, again, I'm telling you, it's not a maybe. It's on the test on Friday. You have a slant. So maybe make a note that your vertical asymptote is the number that goes out here. So I'm going to put a -1 right here. And then across the top, I am going to list all of the coefficients of my numerator, which is 1, 2, and -3. So go ahead and do synthetic division. You only need the first two numbers. You don't need the last number. Just the first two numbers. So take a moment. Hi, thank you. So take a moment. Do your synthetic division. So the first number comes down. Actually, I'm going to do it down here because I need a little bit more space, so I don't have to cramp it. Okay, so the first number just comes down. We don't do anything to that first number. That first number is the slope of my slant, which is m. You all remember y equals mx plus b? Yep, so I just figured out that the m is 1. Okay, so now I'm going to take that 1 and multiply it by -1, and I get -1. And then I add, and I get another 1. That's my y-intercept, or b. So the equation for my slant is y equals 1x plus 1, or you can just write x plus 1. So now we need to graph that. Who remembers how to graph a line? We haven't done that in a long time. Yep, start at B. So B is 1, so let me go ahead and zoom in. So I'm gonna graph that. I'm gonna use this tool. So I'm gonna start here at 1. And then my slope is 1, so I'm going to go up 1 to the right 1, put a point. Up 1 to the right 1, put a point. Up 1 to the right 1, put a point. Now, you all are graphing this on paper. So you can use your ID or something, some kind of straight edge to, draw your line. Unfortunately, I cannot, so I have to put a lot of points. And there's nothing wrong with that. You can put a lot of points too. It is important that you graph this like it needs to be pretty spot on. Because if not, it's going to mess up the graph. So I'm taking my time. And now I'm going to go in and connect it. And when you draw your slant, it could be a dashed line, it could be a solid line, it doesn't matter. So now that you have this down, you don't want to start graphing or connecting points until we have all your asymptotes down. Now that we have that down, we can connect it. Now I'm noticing I feel like I have enough on this side. And then I would like one more point. So I'm going to plug in -8. Don't ask me why. I just picked it. Don't matter. -8. Okay. And it doesn't matter which form you want to use. So you have an option, whichever one you're more comfortable with. You can plug it into this, or you can plug it into the one that you factored. You get the same number either way. So go ahead and take a moment and see what you get. trying to do this in my head, which is probably not a good idea. 64. Nope, I don't feel like it. Okay, what y'all get? You got negative who? Negative 6.4. Anybody else get that? We agree? Okay, I'm gonna go with it. I was gonna try to do it in my brain, but then I was like, I really don't feel like it. I really don't. Okay, so the reason why I recommend you plot this is because your point should be above the slant. So if I have something that's down here, then that tells me that my slant is wrong. Okay? Graphing the slant in the right place is really important for this question on the quiz. So -8. 1, 2, 3, 4, 5, 6. So it's literally right above the slant. All right, so I'm going to roll up the hill. I'm really close. Like your graph should be close to the asymptote. And then I'm going to kind of come in pretty close and then go straight up. When we factor this down, could I cancel anything? Did anything cancel out? No. So we don't have any holes or removable. Maybe you want to write because nothing canceled. Nothing canceled. So now let's do our end behavior. The limit as x approaches negative infinity of f of x is the limit as x approaches positive infinity of f of x is. So this is the left and this is the right. So I'm talking about this arrow right here. This is my left arrow. What is this arrow doing? Is it going up, down, or straight out? What is it doing? Going down. So what am I going to write right here? Good job. And then the right arrow, you got to find the arrow that's furthest to the right. Well, that would be this one. That one is going up. So the limit would be positive infinity. Okay. Is there anything you would like for me? Because we're just about done. The next two go super fast. Is there anything in this question that you would like for me to re-explain? Do you feel like you can do this on the test? Okay. Next one. All we have to do is answer the question. So go ahead and copy it down. We're not graphing it. You have one of these on the test where you don't have to graph it. You just have to answer all of the questions about it. So I'll give you a second. Copy that down. I am thirsty. Okay, so the first question is this a special case? Who says yes? Who says no? Okay, I don't really say much about headphones, but a lot of times kids, they will ask me to repeat the question or the answer because they're not listening. So I really want to make sure you guys are understanding why this is a special case and what that means. Okay. It's a special case because it's not just a fraction. I have this out here. And what that is going to affect is two things. How I find my horizontal asymptote is going to be different. And how I find my x-intercept will be different. Because it's special. Special because of this number. If I take away that number, it's not special. It's just a regular equation that we would do at any old, just like everything else. But this has a +4, so it's special. All right, so let's go through it. Vertical asymptote, what is it and how do you find it? Take the bottom, set it equal to 0. So if x minus 1 equals 0, we get x equals 1. Is this a top-heavy, a bottom-heavy, or a balanced function? Looking at your degree. Yep. So it's a first degree over a first degree, which means that it doesn't have a slant. It's not top-heavy, so that is NA. You cannot have both. You can't have a horizontal and a slant. It's either one or the other. So this one is a horizontal. So what we're going to do is I'm going to divide my leading coefficients, which is 2 and 1. But then because it's special, I have to add the 4. So my horizontal asymptote will be y equals 2 over 1 plus 4. And what would that give you? Y equals what? 6. Okay, now the x-intercept, that's where it's pretty much, it's kind of a lot. Because it's special, I have to set y equal to 0. And then I have to solve it. So let's go ahead and set it up. And we have to solve this for, we have to solve it for x. We can't just take the 2x and set it equal to 0. Because of that +4 is different. First thing I'm going to do is subtract the 4. The next thing I'm going to do is multiply. -4 times x minus 1 equals 2x. Then I'm going to distribute. I'm going to freeze my screen. I want you all to finish it from there. And then we'll see if we agree. So I'm going to give you all a second to try to do that one by yourself. And then we'll see if we get the same answer. And you should get a fraction. All right, I'm gonna go ahead and show you my work. And you tell me if you agree. This is what I would get. This is the full credit answer. In pre-calculus, we are expected to reduce a fraction. So leaving it as 4 over 6 would lose you a half. Not a lot, just a half of a point. So my x-intercept is 2/3 0. Anybody else get that? All right, last step is the y-intercept. How do we find the y-intercept? Substitute in a 0 for x. So that would be y equals 2 times 0 over 0 minus 1 plus 4. Well, we know, because we know some math, that 0 divided by anything is going to give you what? 0. So I'm really just taking this 0 plus 4. So my y-intercept would be at 4. Any questions? All right, last one. Did you all see, I did do videos, even though I said I wasn't going to do videos. One of my students who really does try, she don't give me no problems. She was like, can you please? And I was like, I can't say no to her. So I did it today during 4th period. I only had 40 minutes though, so I went kind of fast. So you might have to, pause it. As you're doing it, I want you to try to do the question and then listen to the answer. All right, so go ahead and copy this one down. And it's our last one. We'll be finished with chapter 4. What are you going to be doing first? Yep, go ahead and start factoring. As soon as you write it down, factor it. I'm going to freeze my screen. You cannot do a shortcut. You have to make a box because A is not 1. Okay, when you're finished factoring, put down your pencil so I can know who's done. I'm going to give y'all a chance to try to do it. Okay, you can go ahead and take a look. So, I put my 2x squared here. And then my -2 here. I have to make my x. A times c is -4. B is -3. Two numbers that will multiply to give me this and add to this are -4 and 1. I put that here. And then I took out the GCF. So this is what I got. So this is what I'm going to use to answer all of my questions. Did anybody else get that? Did I do something wrong? Okay. Anything you need me to explain about how to factor? It's our last question, so we got time. Okay. So vertical asymptote comes from the bottom, and I have two factors. So that means I have 2 vertical asymptotes. We got to take the 2x plus 1, set that equal to 0, and we have to take x minus 2 and set that equal to 0. So go ahead and do that to get your 2 equations. There are 2 vertical asymptotes. One is a fraction, one is not. So for the first one, we're going to subtract the 1 and divide by 2, which is -1/2. For the second one, we're just going to add the 2, which is 2. Okay, is this top heavy, bottom heavy, or balanced? Bottom. Who says bottom heavy? Because we have a first degree and a second degree. So it's bottom heavy, which means we don't have a slant, so we can say NA. But every single bottom heavy function has the same horizontal asymptote, which is y equals what? 0. If it's heavier on the bottom, it's y equals 0. Give y'all a second to write that down. Heavier on the bottom, it's just y equals 0. We don't need to do any synthetic division. We don't have to divide any coefficients. It's just y equals 0. Okay, x-intercepts. This is not a special case, which means we don't have to set it equal to 0. We can just look at the top, which is x plus 2. Take the x plus 2 and set that equal to 0. And you should get -2, 0. And then for your y-intercept, substitute in 0 for x. So what's going to happen is this is going to become 0. This whole term becomes 0. This whole term becomes 0. So all I'm left with is 2 divided by -2. And what is 2 divided by -2? What's 2 divided by -2? -1.